Okay, our last friend, our last function that we're going to be concerned about, that we're going to talk about their inverse, is the tangent. Okay. Our tangent curve, if I draw one cycle of my tangent curve, I'm going to draw it the way I kind of like to draw it. I draw the asymptotes at negative pi over 2 and pi over 2. I know it goes to the origin and a couple anchor points. I know that at pi over 4, the tangent is 1, and that at negative pi over 4, the tangent is negative 1. Ooh, that's messy. And I get something like that and something like that. But I technically have a bunch of them with a bunch of asymptotes that repeat. So the tangent curve, the tangent function isn't just one of these little wiggles, it's a bunch of wiggles. The domain is negative infinity to infinity, except every place we have asymptotes, pi over 2 plus or minus pi k, range negative infinity to infinity. When we do the arctan, we only use one cycle. If we used multiple cycles, we would fail the vertical line test. And you can see what kind of happens is we get the tangent graph, but kind of laying on its side. In the original tangent function, we say the tangent at pi over 4 is equal to 1. In inverse tan or arctan, the inverse tangent of 1 is pi over 4. Now, I think the tangent problems can be some of the trickier ones. I usually can remember the tangents for the tangent of 1 is pi over 4 and negative pi over 4. But the other two tangents we get in the families, the root 3 over 3 and the root 3, I easily confuse those. So best plan is to just to kind of do a little bit of memorization. Ooh. Domain, negative infinity to infinity. Range, if it's just this one cycle, it's negative pi over 2 to pi over 2, not included, which means just like inverse sine, we go quadrants 1 and 4 for our answers, and we use the negative names in quadrant 4. That kind of makes it easy. So our cosine, or inverse cosine, is the only weird one that uses quadrants 1 and 2 of the ones we're going to focus on. Inverse sine and inverse tangent both use quadrants 1 and 4. Inverse sine and inverse tangent both talk about quadrant 4 with their negative name because they want it to be negative pi over 2 to pi over 2. And so one of the things you might do for yourself is just kind of memorize your basic tangent values. Okay. If your tangent is, let's make a little chart here, a tangent value and the theta value. A tangent of 1 is the pi over 4 family. A tangent of root 3 over 3 is pi over 6 family. Tangent wait, let me make sure I'm doing that right. Oh, okay. Sine over cosine. Sine Okay, yeah, that's right. Pi over 3 is just root 3. So you might think about this as pi over 3 is just a 3, but a 6 is kind of like 2 3s. That might be one way to think about it. Other weird ones, 0, 0 and pi, undefined tangent, pi over 2, negative pi over 2. Any of these that are negative going into quadrant 4 will give me negative angles. So using, once again, this is another kind of set of information we got to memorize. But once we get it memorized, we can reproduce these values or make yourself a little legal cheat sheet. As soon as you get your paper, you write a bunch of stuff on it to help you remember. Then doing a problem like tangent of 1 is, well, tangent of positive 1 is positive pi over 4. If I'm only looking at these two quadrants, tangents are positive in quadrant 1, tangents are negative in quadrant 4. Tangent of 0 is 0. Did I write pi down here? Yeah, I shouldn't have done that because pi is not in my restricted area. Pi is all the way over here. Right, so yeah, shouldn't have put pi. Pi does have a tangent of 0, but pi doesn't fit in my restrictions. So only 0 would be the answer for B. Inverse tangent of negative 1, negative pi over 4. Inverse tangent of negative root 3, negative pi over 3. Once again, it's a whole lot of being comfortable with your unit circle values, knowing your tangent values. A good way to do your tangent values always, or a trick you can use, is sine over cosine, or y over x gives you a tangent. So if you're kind of stuck, and like I got stuck there a minute ago and I was like, pi over 3, trying to think pi over 3 versus pi over 6. If I know my ordered pair for pi over 3, the tangent for pi over 3 is the square root of 3 over 2 divided by 1/2. And just by a little fraction multiplication, square root of 3 over 2 times 2 over 1. That can help you remember which one is the square root of 3. Those are the two I forget, square root of 3 and square root of 3 over 3 for pi over 3 and pi over 6. That is the end of the note packet. So what happens next is a lot of practicing. A lot of looking at examples, a lot of practicing, a lot of, if necessary, writing yourself a unit circle diagram, looking at a unit circle diagram, working off of a unit circle diagram until you start to get comfortable. What you're going to do today in class is you have a practice worksheet to do, and you have a practice Schoology assignment to do. The good thing about the Schoology assignment is it's going to be self-checking. It's going to give you some information about how well you're doing it. So I would definitely recommend working through that first, and then the worksheet is a secondary practice for you. All right. Thanks for paying attention to this and going through it. Thanks for doing your work today, and hopefully I'll be able to see you soon.